Well, pre-calculus classes, once again, good morning, good afternoon, or good evening. I know, again, whenever you may be watching these may be different for everyone. We are going to go ahead and start into section 5.2 today, and that's going to deal with solving trig equations. And as you're solving for trig equations, there's a couple of things that you have to do. First, it does have to involve just a single trig function, so occasionally you'll even have to transform something to get there. But then what you're always going to do is isolate the actual trig function on one side of the equation, then solve for the variable. Now, a lot of the time what that will entail is using a unit circle, if you have a copy of that handy. So, first two will be kind of some introductory problems to work our way up. This first one, 2 sine x minus 1 equals 0. Well, what we're going to do, isolate the trig function. So add 1, divide by 2. So 2 sine x equals 1, divide by 2. So the sine of x equals a half. Now, when it is an exact unit circle value, you don't officially have to take the inverse, but that's essentially what you're doing. When it is an exact value, sine of x is a half at 2 spots. Now, I realize this one had a 30-degree label, but we are going to have you use radians. So one of the 2 spots is at either 30 or pi over 6. The other spot is directly across from it at 5 pi over 6. Again, those are the 2 places where sine has a y value of a half. So our solutions are pi over 6 and 5 pi over 6. Now, for our next equation, sine of x plus radical 2 equals negative sine of x. A couple of different ways you can look at it. Again, we're going to isolate the trig function on one side of the equation. For this one, probably suggest moving sine of x over. And so then radical 2 equals, well, negative sine minus another sine is negative 2 sine x, and then divide. So when we divide the negative 2 over, that's going to give you negative square root of 2 over 2 equals sine of x. Again, we're looking at on our unit circle, where are those locations? Well, y values are here and here, which corresponds to 5 pi and 7 pi over 4. So again, those are a couple of intro type questions to get us started. Now, as we move to the next page, a couple of different things are going to show up. When a question says to give all solutions, that's where we are going to have to account for the fact that when you work with a unit circle, in theory, you could have had for the question we just looked at, an answer at 5 pi over 4. Well, we can continue to go around the unit circle forever. So that's something that we are going to count for when it says give all solutions. The other thing that will also come into play here is that when you have an equation like 2 cosine of 3t minus 1 equals 0, there will be a period change, which impacts us when we get to part B. So for this one, first we are going to isolate the trig function. Add the 1, divide by 2. So cosine 3t equals 1/2. Now, from there, again, we're looking at where does cosine equal 1/2. The 2 spots are up here at pi over 3 and down here, which is 5 pi over 3. Now, the other thing, like I said, there is a period change. That's what we're going to address next. So 3t will equal pi over 3. 3t will also equal 5 pi over 3. Now, because you can go around the unit circle an infinite number of times, we are going to add in plus 2n pi to each of these. Now, the last thing that we need to do is now get t by itself. And, either think of it as dividing by 3. I'll admit for these, I actually prefer to think about it as we're going to multiply by the reciprocal. So when we do that, 1/3 and 3 cancel. T will equal, when I distribute pi over 3 with the third, pi over 9 plus 2n pi over 3. And the reason why it's 2n pi over 3, well, if you remember, the period is 2 pi over b. Well, if you take 2 pi divided by 3, our new period for this trig function is 2/3 pi. Now, for this one, 1/3 times 3, again, those cancel. When I distribute, 5 pi over 3 times the third gives us 5 pi over 9, again, plus 2n pi over 3. So that's what we're looking at if the question asks you for all solutions. Now, the other thing that we kind of were dealing with on the first two questions were what are the solutions from 0 to 2 pi? Well, the issue now, because the period is shifted down to just 2 pi over 3, we have two solutions from 0 to 2 pi over 3. Pi over 9 is, somewhere in here. 5 pi over 9 is right around here. So we have those two solutions. Well, there will be another two solutions from 2 pi over 3 to 4 pi over 3, and two more solutions from 4 pi over 3 to 2 pi. So this is where basically to give all of these solutions on the interval 0 to 2 pi, well, we're going to start listing the two we just found. Then we are going to add 2 pi over 3, which is what this accounts for. Think of it as we are going to add in one interval here. Now, the only other issue we do run across is we do have to get a common denominator here. So our next solutions will be pi over 9 plus 6 pi over 9 and 5 pi over 9 plus 6 pi over 9. Well, when you add those, you end up with 7 pi over 9 and 11 pi over 9. Now, we do have to do that one more time. Again, because our period is now down to 2 pi over 3. Well, that happens once, twice, 3 times. Basically, I like to always say you can determine the number or the sets of solutions you're going to have based off of B. Here's our first set of solutions. Here is our second set of solutions. Now we're going to add another 6 pi over 9. And when we do that, 6 plus 7 is 13 pi over 9. 11 and 6 is 17 pi over 9. From 0 to 2 pi, another way to think of this, since our denominator is 9, basically it's like our answers cannot go past 18 pi over 9. And these two do not. So, again, pi over 9, 5 pi over 9. There's your first set of solutions with the period of 2 pi over 3. Here is your second set of solutions for that next 2 pi over 3. So here would be kind of like we were adding where n is 1. For these two, when we add it a second time, now n is 2. So that's kind of what's happening here. All right, for our next problem, tangent of 4x equals 1. Again, give all solutions. Well, to start, here the nice thing is we have the trig function already isolated. So now we're essentially just looking at where does tangent equal 1 on our unit circle. Well, tangent equals 1 when you take, if you remember, tangent is sine over cosine. So when we take y over x, the tangent of 45 is pi over 4. So here, 4x equals pi over 4. Now, from here, tangent, if you remember, again, I know it's been a little while since we've talked about it, tangent only has a period of pi. So I'm only going to list one answer initially, and then plus n pi. Now the last thing we have to do here, again, multiply by 1/4. So x will equal, when you distribute, pi over 16 plus n pi over 4. So those are all solutions. Now, from here we are looking at give all solutions on the interval from 0 to 2 pi. Now, I will tell you there are going to be quite a few of these. So as we do go from here, I'm going to start out pi over 16. Now, the other thing that you might even want to consider, 2 pi is the same thing as 32 over 16. Now, we are going to start by adding pi over 4, which, once again, get a common denominator of 4 pi over 16. So our first solution is pi over 16. Now, when you add pi over 16 plus 4 pi over 16, well, that's going to give us 5 pi over 16. Well, again, basically what we're going to have to do is keep adding those increments of 4 pi over 16 till we get to 32 over 16. 5 and 4 is 9. 9 and 4 is 13 pi over 16. So basically here are the two answers from what would have initially been the first rotation. Here's the second rotation. We are going to have to look at 4 rotations. So coming down here now, 13 pi over 16 plus 4 pi over 16, 17. Add 4 pi over 16 again, 21. $25. And then one final solution is 29 pi over 16. Again, first rotation, second, third, and fourth, due to your period being shrunk from pi to pi over 4. And again, if you were to add 4 pi over 16 again, you would be past 2 pi. So that's another way to know that you're done. All right, one final question. 2 sine squared of 2x equals 1. First thing that we are going to do is divide by 2. So sine squared 2x equals 1/2. Now, the one thing you do have to be careful about here is when you take the square root, it is going to be both positive and negative. Now, when you do this, square root of 1/2 basically becomes 1 over radical 2, because I am square rooting both. When I rationalize, I have sine of 2x equals positive and negative radical 2 over 2. Now notice here, answers only from 0 to 2 pi. Now, 2x will equal radical 2 over 2, pi over 4. Even though it is just 0 to 2 pi, we are going to have to account for that plus 2n pi. Well, the next place where sine is radical 2 over 2 is at 3 pi over 4. plus 2n pi. Then for the negatives, 5 pi over 4 and 7 pi over 4. So this does end up being a little bit more involved as we work through this one. Now, once again, we are going to multiply everything by the reciprocal here. So x will equal pi over 8 plus n pi. X will equal 3 pi over 8 plus n pi. 5 pi over 8 plus n pi, and 7 pi over 8 plus n pi. We have more solutions because we do have to worry about both positive and negative. Now, these all are from 0 to pi. Basically, because of the 2x, 2 pi over b, our period goes from 0 to pi. So these are the 4 answers from the top half, essentially, of the circle. Now we're going to have to add pi to each of those to get the second answer. So I am going to box in these 4. Now I'm going to take pi over 8 plus pi, which again, getting a common denominator, is pi over 8 plus 8 pi over 8, which is 9 pi over 8. Then we do the same thing, 3 pi over 8 plus 8 pi over 8, 11 pi over 8. 5 pi over 8 plus 8 pi over 8, 13 pi over 8. And then our final solution we do with 7 pi over 8, which 15 pi over 8. So those are the other 4 solutions from 0 to 2 pi, which again cannot go past 16 pi over 8. There is a corresponding section on Pearson 5.5 number 1 for these style of problems.